Okay, so here we see a typical transimpedance amplifier circuit as shown here in the right, that converts an input current from the photodiode to an equivalent and proportionate output voltage. So the system is divided into two parts. To the left side you have an input signal source in the form of square wave, and that is applied to a laser diode here. So laser diode emits light pulses as shown. So and those light pulses are received by the photodiode, which is the second part of the circuit right here, and therefore the system is divided into two parts. One is called as transmission part, and this side is called as reception or receiving part. Now when the light falls on the photodiode through the laser, this diode is already connected in a reverse bias condition. Anode is connected to the voltage negative VB, and the cathode is connected to this node, which is the inverting input of a differential amplifier with a gain A. And because of the light falling on the photodiode, the diode starts conducting a current in a reverse bias mode. The current is labeled as IP, and the direction of the current is indicated by this arrow right here, and therefore the circuit is completed. The output voltage is developed here, and the direction of the current is from the output through the feedback resistance RF and through the diode up to this, and that's why the arrow indicates the direction of the current flow. Since the current flows through the feedback resistor RF, the voltage is developed across the RF with a polarity as shown, and we can get the expression of the output voltage. V out is equal to negative of IP times RF, whereas IP is the diode current and RF is the feedback resistor. So you see the gain of the circuit is being set by the feedback resistor RF. The capacitor CF is there to stabilize the output voltage in a practical applications. So this is how the circuit is working. So you see that you can always see there is a pole in the frequency response of the circuit. You have a pole. The time constant is set by the product of capacitor and the resistor RF, and the input pole frequency is 1/2 pi CF times RF. So you can see that this is transimpedance amplifier, where impedance is the parallel combination. The impedance of the circuit is given as Z feedback resistor. You see that is 1/j omega C into RF divided by 1/j omega C plus RF. So it's a parallel combination of resistor RF and CF. So that's your input impedance. You can see that. Okay, so hope you like this video. If you did so, share it with others and subscribe.